In this problem, we're given the expected return, standard deviation, and correlations amongst 3 different stocks. We're told that we have a portfolio of these stocks where we have an equal investment in each one. And the question is, what's the expected portfolio return and what's the standard deviation of the portfolio returns? So the first thing to do with this question is to calculate the weights of each one of our 3 stocks. Because we have an equal investment in each stock, the weight on stock A is going to be equal to the weight on stock B, which is going to be equal to the weight on stock C. Moreover, because these weights sum to 1, we know that each one of these weights is going to be 1 over 3, or 33.3% of the portfolio. Next, we can calculate the expected portfolio return. And so we do this by recalling that the expected portfolio return is going to be a weighted average of the expected returns of our underlying stocks. And so in this case, the expected portfolio return is going to be the weight of A on A, which is 1 over 3, times the expected return on A, which is 10%, plus the weight on B times the expected return of B, which is 12%, plus the weight on C times the expected return on C, which is 0.08. And when we multiply everything out together and add them all up, we calculate that the expected portfolio return is going to be 10%. Next, we can calculate the variance on the returns of this portfolio. And so this is going to be a little bit more complicated than calculating the expected returns, because not only do we have to take into consideration the variance of the individual securities, but we also have to consider their cross effects. And so their cross effects are going to be measured by the covariance between every single pair of the underlying stocks in our portfolio. And so let's start by calculating the variance of each one of our stocks. So recall that the variance of a stock is going to be equal to the standard deviation squared. So in this case, the variance of stock A is going to be equal to the standard deviation of stock A squared. Standard deviation is 20%, or 0.2, so this is going to be equal to 0.2 squared, which is equal to 0.04. Similarly, the variance on B is going to be equal to 0.3 squared, which is 0.09. And the variance on C is going to be 0.25 squared, which is equal to 0.0625. Next, let's calculate the covariance terms. So recall that the covariance between stock A and stock B is going to be equal to the correlation between stock A and stock B times the standard deviation of stock A times the standard deviation of stock B. And so in this case, the correlation between stock A and stock B can be found in our correlation matrix. And so we have stock A here and stock B. And so the correlation between stock A and stock B is going to be equal to 0.2. Notice that the correlation between stock B and stock A is also 0.2. So that's why this correlation matrix is symmetric. So the correlation between stock A and stock B is 0.2. The standard deviation on stock A is also 0.2. And the standard deviation of stock B is 0.3. And so if we multiply that all out together, we find that the covariance between these 2 stocks is 0.012. And so we can go through the same process and calculate the covariance between stock A and stock C, and the covariance between stock B and stock C. When we do that, we find that this covariance is equal to 0.005, and the covariance between stock B and stock C is equal to 0.03. And so now we have all the information we need to plug into our variance equation. And when we plug everything in, we calculate that the variance on the portfolio's returns is going to be 0.031 83. And so the last step is to calculate the standard deviation of the portfolio's returns. And we do this by taking the square root of the variance. And so if we take the square root of the variance that we just calculated, we see that the standard deviation of this portfolio's returns is going to be 17.8%. And so one thing to notice is that the riskiness of this portfolio, as measured by its standard deviation, is smaller than the standard deviation of each one of the individual stocks that go into the portfolio. And so this result is due to diversification. And in particular, because these stocks weren't perfectly correlated, we were actually able to combine them and reduce the fluctuations within our portfolio. And so this concept of diversification is going to be really important, and we're going to use it throughout this class.